Good evening, everyone. Today's session is not a typical session of Meetup. We are going to cover multi-dimensional aspects of the sentiment analysis, what we call sometimes MCS, Meaningful Connection Score. When I say multiple facets or multiple aspects of this, I mean we are going to cover the design, the software design of the solution, the actual algorithm. How is it related to the business atmosphere? How does it affect the brand's performance? And also, how is the sentiment or connection is related to the agent performance in the call center? So all these aspects will be covered within this talk. And we are going to have also multiple speakers. We are going to have 4 additional speakers. After me, Lital Chacham from the R&D will talk about the software design. Then Dr. Michael Natapov will talk about the actual algorithm and how was it developed. Then Neta Barkay will talk about the business implication of this, how this affects the performance of the business. And finally, Dr. Naama Tepper will talk about how the sentiment affects the performance of the agent. So this is what we are going to cover now. I will just give you the overview and lead into this discussion. One more issue about questions. If you have questions that are related to the talk, then please do it during the talk, but otherwise we prefer to take all questions at the end and address them. Thank you. Okay, so who we are, LivePerson. LivePerson, we are a company, we are a technology company. Some people sometimes think that we are a company that are actually holding the agents behind the scenes, so no, this is not the case. We are a technology company. Our bread and butter, or our basic solution, is a meaningful communication platform where the brands can connect with the consumers, vice versa. In terms of share, we are the market leader in the share of chat for business. We are already 21 years old, not a young company. We have 1,200 employees worldwide, 440, something like this, here in Israel, where the R&D is located, and some other aspects of the business. We are conducting 30 million chats a year, and we are monitoring somewhere about 1.5 billion visitors every month. This is about the scale of the company. The data science group in LivePerson, most of the people that will talk today are from the data science group. The data science group is working on 3 major domains here. One domain is the supervised machine learning. We are embedding a supervised machine learning model within the platform that is tailored for every customer, for every brand, based on the data that we collect from this brand. And this machine learning algorithm in real time scores the visitors in order to identify the top prospects for engagement and to engage them. And it is working in a large scale, calculating approximately 1 billion scores a day. We are working on automation techniques in the machine learning. About all these cycles that I told you is about creating the machine learning model and deploying it in an automatic way on a daily basis for every customer from our large customer portfolio. And this scoring is actionable because we actually use it for targeting. So that's about the supervised machine learning area. Second is the queuing and routing. In this area, we are doing work about managing queues in order to avoid too large queues and also avoid the other way when we have no queues and the agents are not having enough prospects to work on. We are doing routing in order to find the right agent for the opportunity and match accordingly. And these are the work that we are doing in this area. The last area is the area that we are going to focus today, is about the NLP, natural language processing. We are going to show you the sentiment model that we have and how did we build it and what are the foundations in the software that we have for this solution. We have also topic extraction, something that we are not going to discuss today, just to give you the overview. And we are working on intent extraction in order to better understand what the customer is telling us in order to give him the right answer. So this is what we are doing mainly. What are we going to discuss today? So first, we are going to discuss the real-time sentiment engine that we have in terms of architecture. This is going to be the first speaker. Then the core NLP algorithm, second speaker after me. Then how this emotion, customer emotion, are affecting the brand performance in terms of business performance. And finally, how these customer emotions are affecting the agent's behavior and performance. So these are the issues that we are going to cover in this talk. So now, Lital, architecture.
Okay. Hi, I'm Lital. I'm a developer here at LivePerson. I'm part of the team that developed the real-time sentiment engine, and I'm going to focus on its architecture. So you know when you go on a website sometimes and there is a pop-up that jumps and asks you if you want to chat with the representative of the site, if you want to ask him questions or complain about something. So this is what we do here at LivePerson. In our case, the representative is a real live person, as the name suggests. So we have the visitor, he's on the site, he's chatting with the agent. We take the text of the chat, specifically the visitor lines, analyze it, and compute a sentiment score out of it. This sentiment score is an indication for the visitor emotion, whether he's happy, unhappy, satisfied, or not satisfied. We take this sentiment indicator and return it back to the agent and agent manager while the chat is still going on. Now, how do we use it? The agent, when he's chatting, he can chat with more than one person at the same time. So while he's chatting, he has the sentiment indicator. This can help him keep track of the chats. He can notice the chats that are more negative, maybe pay them more attention, and keep them and direct them to a more positive place. In the agent manager view, there is much more data about the chats. There is data about the visitor name, about the country the visitor comes from, the agent name, the skill of the agent, and we also have the sentiment indicator. So here you can see there is a large group of chats since the agent manager sees all the chats on the website. And now he has also the sentiment indicator. So he has some of the chat has a smiley face, which means they are positive chats. Some has a frowny face, which means they are negative chats. And some have no face, which means they are neutral. So now, from this large group of chats, he can filter out, using this sentiment indicator, a smaller group and investigate it. These chats are chats with visitor emotions, which means they might be more interested in him. He can check the chats with negative emotion and maybe help the agent handle them, or maybe even intervene in the chat. So in order for the sentiment indicator to be really effective, it is important all of this will happen in real time. So how do we do it in real time? First, we have to take a good look of the data we have here at LivePerson. We have a large amount of data here. We have about 100 million monitored visitors per day. They generate about 1 to 2 million chats per day, and they consist of about 20 million messages per day. This can be calculated as 250 messages per second on average, and during peak time, about 2,500. Peak time here is sometimes days where there is a lot of traffic on the net, days such as Black Friday or Cyber Monday. So we have this large amount of data that we want to process. And for that, we wanted to build an architecture that will help us process this amount of data and will be able to scale up when this data will get even bigger. So this is our architecture. This is the real-time data flow. Let's start from the top. We have here a few producers. We have in LivePerson all kinds of producers. The one that is relevant for our data flow is the chat producer. So the chat producer produces all kinds of chat data. It produces the chat metadata, such as chat start time, chat end time, the chat lines. All of these are written into the event bus as events. We have the event bus enabled us a way to form a communication between the producers and consumers without them knowing about each other. So now we have a consumer, our sentiment processor, that can read the data of the chat, consume it, analyze it, and generate a sentiment score. This sentiment score is also kept in a new event and is written back to the event bus. Now, other consumers can read the new event with the sentiment score and use it for their purposes. During the processing, we are using Couchbase DB as our persistent layer to store the sentiment model. And the sentiment processor itself, it resides on a Storm framework. This framework enables, which is a distributed system for real-time processing, enables us to scale up easily if needed, if more data will pass through the data flow. So this is the basics of our architecture. And now let's dive a bit to the sentiment processor. What exactly are we doing in order to calculate the sentiment score? So we have as an input the text, the chat data. We process it, and we output the sentiment score. We have few steps in the analysis. The first one is the language detection. We take the text, and we detect its language. Then we parse the text. We parse it using Stanford NLP library. We parse the text into sentences and words. Then we choose the relevant sentiment model, which in the most basic terms, it assigns negative or positive values to specific words. Then we calculate a score for the message. And at the end, we calculate a score for the entire chat up to that point. Now, the messages keep coming in while the chat is still going on. So we have to update the chat score with the new messages. So at each time, the chat score is reflecting the current state of the sentiment of the chat. So the first step, which is the language detection, currently our sentiment model supports only English. We plan to support other languages in the future. The next one should be French. We had some challenges when trying to detect the language of the text. We realized that since our chat data is probably more of a shorter text, when most of the people use all kinds of abbreviations in it, it is harder to detect the language. There are less features in the chat itself. So we used for it a Saibuzu language detection library, and we configure it with a short messages profile that was built on tweets data. This tweets data is more close to our chat data. It's more similar to it. So we got better results. After that, we are parsing the text, and then we need to score the messages. In order to score, there are 2 points I would like to mention about the process of scoring. First, since our development process was parallel to the research process, we knew we had to make sure it will be easy to replace the sentiment engine with no need for much development. So we built our our architecture, in a way, it will be very easy to replace it. And we really did replaced it a few times during the development. Another point is that we wanted to have the ability to update the sentiment model dynamically with no need for deployment. We need the ability to update the sentiment models in a language level and in a brand level. It's important to do that. I will try to explain why we need a sentiment model in the brand level by the following example. Let's think of the word nasty. Nasty in general is a negative word, as you all know. But in the following context of the site Nasty Girl, it's not negative. So here we have to build a specific sentiment model for this site, Nasty Girl, in order to generate chats with accurate scores. So this is why we had to do it. And this is just a glimpse of the sentiment model. And now Michael will elaborate more about it.
Okay, hi. My name is I'm Mikhail Natopov, and Shlomo introduced me as a doctor. So I should say that I'm graduated from the Technion with PhD in mathematics. And I spent several years in postdoctoral positions. And 3.5 years ago, I joined LivePerson as a data scientist. And then recently, a year or so, I started to work on our text analytics projects and on the sentiment analysis in particular. And I'm going to tell you a story of development of our sentiment analysis algorithm, starting from tests. And we started from trying to adopt an existing out-of-the-box solutions, validated them, and we choose to build our own data-driven algorithm. On the way, I will tell you how we validate, how we measure the success or the lack of success of a sentiment model, and all this with emphasis on a data-driven decision that we've taken on our way. So we tested quite a bunch of out-of-the-box solutions. I'll talk about Stanford more than other because we had a longer story with it. So one of the reasons is because back 3 years ago, probably today, it's the most advanced and best performing solution. It's a neural network which is built not just on labeled sentences labeled by sentiment, but on the grammatical structures built upon the sentences. So the sentence is just a root of this tree. So all the subphrases of the semantic tree is built upon the sentence, and all the roots and branches of this tree are the subphrases of the sentence. They are also labeled, and the algorithm is trained upon it. It's important because we try to do something similar. And it reported 85% of accuracy on positive, negative reviews. So let's understand what does it mean, 85% of accuracy, what does it mean in general, how it works on our chats or messages, why it's not a good measure, and what metric we do use to evaluate algorithms of this kind, and see why we failed actually to work with this kind of solutions and choose to build our own. So let me just say in the next few slides, all the data is synthetic, is not real, is a mock-up, just for the sake of definitions. So here I want to explain what accuracy means. So let's suppose we have 100 texts. Let's think about it as reviews. Half of them are positive, half of them are negative. And a hypothetical model, I'm not talking now about the Stanford or our model, a hypothetical model, detects 45 negative messages correctly, and 40 positive messages correctly. So overall, we have 85 correct detections. And in this case, we say that we have 85% of accuracy. This is an example of asymmetric data. Our chats are built somewhat different. The bulk of our chat sentences are neutral. And this example mock up our data. Still, it's not real one, but let's assume we have 800. We have overall 1,000 messages, and 800 of them are neutral, and somewhat about, 110 are positive, 90 negative. And the same model which we are talking about performs, indicates sentiment like in this table. So we see 745 correct predictions. It translates to 78.5% of accuracy. And while I've been talking, I believe many of you got a better solution for this data, which is a trivial model which predicts everything is neutral. If you predict everything is neutral, you detect correctly 800 sentences out of that 1,000. So you got 80% of precision, which is better than this model in terms of accuracy. So what do I want to say? That accuracy is not a good measure for us, because what we want to do is to detect negative and positive emotion in chats correctly, and not just some abstract accuracy of it. So we should concentrate on metrics which measure the performance on negative class and positive class, on both of them or some combination of them. So there are metrics that I'm going to explain that do exactly that. The first is precision, and I'll explain what precision means on negative class. So our model detects 100 sentences as negative. At 45 sentences, it's correct. It means this is the definition of the precision. So this is the precision, the rate of correct prediction rate is the precision. So we have 45% of negative precision. Recall measures the coverage of the prediction. So if we have overall 90 negative sentences, and the model is correct in 45 cases, in half of them, so we have a recall of 50%. So similarly, we define positive and positive precision and positive recall, and we have somehow to balance, to choose between these metrics and to optimize them together, or optimize some function of them, or choose one or two of them and to optimize them. And what we did is, and what we are doing actually all the time, we optimize negative precision. And that means the accuracy, the precision on negative class. It's more or less, it's not more or less, it's exactly, it's a business decision, product decision. We are interested in detecting negative emotion because that's what our brands are interested in. They want to get alerts on problems rather than to know that their customers are happy. And they are not interested to have false alarms. And that's exactly where precision comes to play. So the higher the precision, the smaller the false alarm rate. And now, let's forget about these examples, or remember them if you want, but next slide is about the performance of Stanford on our chats. So now, we measure negative precision of the original out-of-the-box Stanford engine on our sentences. And I would like to ask you, what is your best guess? Remember 85 accuracy on positive, negative, and so and so.
40%.
Say it again?
20%.
10?
20.
You said 20. No, it's
20 to 30.
No, the first guess was correct. That's all we got at the very beginning. By the way, other algorithms perform the same. But we've chosen to go and to try to improve Stanford because of this very feature of it, that it is trainable. We could, what we have chosen to do is to build our own corpus, to label the sentences from our chats, and to train the algorithm of our own corpus. So our engineers built a nice tool. We couldn't outsource it to crowdsourcing because of the security reasons, so we did it in-house. So our coworkers we sampled the chats, we sampled the sentences from chats, and we built parse trees upon these sentences, and we gave it to label for sentiment, these 5 categories of sentiment for each phrase and subphrase, sentence, subsentence. Worked months, few months, and we got some hundreds and thousands of sentences, and we built some I would say dozens of models, and we got fantastic improvement. And again, I ask you to guess. No, much better. 35%, I don't say the exact figure because it depends on the brand where we check it, and etc. So indeed, it's a failure. So what's the main reason for failure? You may guess easily after what have been already said. The main reason is that our data is so different from what people are used to work with, like movie reviews, that first of all, it's characterized by very short sentences, not well structured. Short sentences, such that sometimes it's just single word or single symbol or just smiley or some LOL. And it is characterized by extensive punctuation, by capitalization, infinitely many misspellings, obscenity. So all the things you can think about, they are different from what we are used to see in movie reviews, restaurant reviews, etc. One example is better. So you just saw a synthetic chat example. Here is a real chat example. So here you can see many of the phenomena that I already mentioned. Short sentences, misspellings, no beginning, no end of a sentence, sort of at the end. So it's an angry customer can't access my account service on a certain brand, and there is an overhead of automatic response and relevant agent remarks, but that's the actual stuff that we are interested to detect, its sentiment. So what do we do to catch it? What do we do to capture this phenomena? We decided to build our own engine, which is the main idea of it is to look close at our data, to use it. Not to go to the sophisticated structure, but to use a good known lexicon-based paradigm, just to build word of bags with special meanings, positive words, negative words, special smileys, politeness, rudeness, to catch all these phenomena, to formulate the rules that put them together. Again, the main idea is data-driven, to see how we can formulate the rules which reflect our data structure. And okay, so now I'll dive in a little detail of the main steps of our algorithm. So first, we replace building the parse tree by simple lexical parsing. What we need, all we are doing is we decompose message into the sentences, and each sentence into the tokens. So this is the original text and this is the parsed text, and you are not supposed to see the difference. But all we did here is separated comma and "I'll" into 2 tokens. And here is the parse tree of the same sentence built for the Stanford. And here we gained an order of magnitude improvement in performance. By the way, it's just a nice byproduct. This takes seconds. This takes nothing. Next, we look at our data and we build these bags of words. So if you are going online, you download in a second positive words, negative words, etc., etc. What is wrong with these bags of words is that they contain words that are not they do not fit our data. For example, a very nice example that I will elaborate a little bit later. The word "nice," not this nice. Nice, have a nice day. The word "nice" is not positive. Okay, and every bag of words that you find online, and if you think about this, "nice" is a positive word, not in our case. So we decided not to use the word "nice" as an indication of positive emotion, and I will explain later. So here are some positive examples. Great, helpful, fantastic. These words may be emotional, and they may be operational, cancel, or I don't know, cancel, refund, etc., etc. So emotion can be decoded in these operational words. Next, we should consider these words in the context. Good is good, but not good is bad. And there are 5. The context, by context we mean either negation or amplification of the word. So there are or their combination. So there are 5 possible contexts of a word which eventually define the sentiment score of this word. We call these words anchors. So from now I'll use this word. So there are. You just saw an example of positive anchor. Good is positive anchor. It can be negative. There are 2 levels of intensity. Very positive, very negative, positive, negative. And there is one which I want to talk a little bit more. I already mentioned it. Weak positive is a fake positive. These are the words which are, without context, behave more neutral, like neutral. But if you put them in negation context, they behave more positive, which means become negative. Let's see an example to make it clear. Have a nice day. Nice is neutral. Have a nice day is a neutral, polite expression. This, whenever I negate nice, I became negative. Similarly, I would like to. I would like to is responsible for 95% of usages of word like as is in our chats. 95%. So in 95% cases, it's neutral. But whenever it is negated, it is negative. So this is like and nice are not positive in full sense, in a strict sense. So let's wrap up these steps that we have until now. So we have a sentence. We determine anchors in it. So potentially emotionally charged words. Here it is disconnected and approve. We put them in the context. Context is just a few words preceding the anchor. And in the context, in context, we look for negation on amplification. In this case, we find it. It didn't approve. So approve from potentially positive becomes negative. So this sentence has two indications for negative sentiment in it. That's not all. Next step is to consider the sentence as a whole. And here we take in account the special features of the sentence, like if it is a question versus the statement, if it contains smileys, if it is polite or not polite, rude, not rude, contains extensive punctuation or not contain doesn't contain. So here's two examples of this sentence, what we call sentence level rule. Here's the same construct I don't like in two sentences. In the first one, it is negative. In the second one, it is neutral. What is the return policy in case I don't like it? It's a neutral sentence. And how do we know that it is a neutral? How do we know it or not? The word what is responsible. So we detect it as a question. So we say question reduces the sentiment. And so this one we report as a negative, and this one is as a neutral. One more example is the extensive punctuation, multiple question mark. So hello is a greeting. Hello, like hello, where are you? That's the context. It's evidently negative. Okay, so until now we have a sentence. We look for anchors in it, put it in context. This gives us initial score. Then we apply sentence level rules. And we change or even alternate the score of the sentence. And the next steps are aggregations. So if we have a message which consists of few words or few sentences, we add all the scores together. Then we aggregate the last message. We put the score of the last message with the scores of the previous messages, and we have the online score. And if needed, we display it as in Rital's slides with a green or red smiley frowning. So that's the online algorithm. And here's our performance. And okay, these are our internal names for this improved Stanford model, Stanford algorithms, which is trained on our data. And it is you just may treat it as a timeline. That's what happened. We worked half a year to get up here to this 35%, and another 2 months to double the performance. So we are happy with this. One remark, I want to get back to the Nasty Gal example. There are brands, okay, so our chats are not uniform, are not homogeneous. They differ by geolocation, by industry, by sales versus service, and by brand. So there are brands which use the words which in general negative or positive, but they are name of brands, they have names of customer. So here another glimpse in our data. So what you are seeing here is the sum of the most frequent negative words in our chats. So problem, issue, wrong, error, lost is just literally the six most used frequent words. This is from the second 10, third 10, frustrating appears in the fourth 10. These are some quite, you may expect these words to be up there in the frequency list. And that's what happens in the Nasty Gal example. The word nasty is way more useful. This is just the one day frequency table. Is the most useful negative word on a certain site, on our certain customer, is nastiness. So that's the indication. It's not an algorithm, but that's an indication. That's the beginning of the algorithm of detecting this problematic words, or not problematic, interesting words, and to excluding them from a model per account, per vertical, per industry, etc. So just word count, nothing else. It's amazing. So that's what I want to finish with this slide. Whenever we started to look at, we became intimate with our data, we succeeded. That's the, yeah.
Why it's difficult to get to much more high percentage of recognition, like 90% of recognition? What is the problem?
You ask why we 65, that's what we get. First of all, it's a work in process. Still, we are improving. The ceiling of it is not 90 and not 95, not 100, of course, because people don't see. Even people, the humans, don't see obvious. So the maximum we can get is 85%. 85% is the deep maximum. And again, it just demands too much effort. Maybe we wouldn't work 3 months for improving by 2%, and instead we develop French. That's another of our considerations.
Could you give an example of dialogue that it's difficult to understand that it's negative and it's difficult to compute?
Any kind of sarcasm, any kind of non-direct words. We do know to recognize I've been waiting for 20 minutes, but I can't recognize I could grow old while waiting you. You know, Kilo. there are some wordings that we just don't want to put an effort in this direction. Okay, we do miss. Let's continue later. Yes, please.
You've shown a precision measure of 60%. What recall did you get for that?
We are on recall of between 20 to 30% of recall. 20, 25, 30, maybe 30% of recall.
25 with
Yes.
60%
Yes.
precision.
Yes. Again, it is not a goal to get a recall, because sometimes we have 50% of negative emotion on a certain brain. We don't want to alert on 50%. We want to alert only on a high, where we're highly confident in our results. Okay, yes?
Were agents used to score their own conversations?
No. No.
It's not the joke. Well, I'm saying, like, let's
Oh,
say, for example, a live agent, the customer just said, I am very pissed off. And then the agent, detecting obviously that this is a very negative emotion, says negative, adds it to the algorithm, adds it to the database, and the algorithm learns it.
The agent has an agenda.
How do you know in general that he gives correct indication?
Yes.
How do you believe him?
Well, at the end, the
Ah,
manager of the
okay.
database receives, he sees a bunch of red stuff, and if he says,
No, the answer is no. we thought about this, and we decided that we don't want to mess with.
How do you interact with the algorithm? So let's say you saw some word like nasty, and you figured out it's not really it's not an indication of a negative behavior, and then you would like to affect your algorithm so that the next time you encounter this word, the results will be more like human.
I have special for Nightingale example, for Nightingale brand. I have a special bag of words which is exclusions, which consist of one word. I'm saying this explicitly. Ignore word nasty in this case, and treat as a negative in all the other cases. So in the bottom model, in a generic language model, there is a word nasty as a negative, and there is small exclusion, which is responsible for this brand.
So the application was like brain. In other words, one model, when you sold it to Nasty Girl, you had to specifically configure it to Nasty
Yes,
Girl, and
yes.
when you sold it to Coca-Cola,
As I get a chat message, I know to attribute it to the account. So I have a key. I attribute it to a language, as Lital said, to account, to skill, to not skill, vertical, and that's the key. And for each key, so we have a basic language model is the biggest one, and we have small additions or exclusions per account.
Are the scores per words? Like if you have two words, one is negative and one is positive, or two negatives, or whatever.
Add them. Just add them. So that they may cancel each other. Yes.
Okay, so you may have a positive statement and then a negative one, and it will be negative. It will be neutral. You called it before, right?
Yes.
but it's not happening very much.
Indeed. That's the. All the decisions we get, it's not something that is obvious, something that we got automatically. We thought about how to treat these sentences and decided that that's the way by looking at our data. Yeah. Yes, please.
Do you get an online feedback from your agent? I mean, if
No. That's the question we asked. No, we decided not to mess with agents. Yeah. Yes.
Are you adjusting the brand level model automatically or manually? And what size is the brand or the language level model?
Of a model.
Yeah.
Model has thousands of words, of positive and negative thousands, and some tens and hundreds of special words, like question words, negation words, amplification words, is tens, manually. Just manually, and each word, it's just word by word, we made a statistical analysis of it. Yeah.
What is the feedback from the customers, if any, for this precision?
Oh, it's not to me. It's a question somebody else will answer. Shlomo.
This product or feature is relatively new in our platform. We have some very promising applications so far, but we are still working on leveraging it to all our customers. It's not there yet.
We do not. I didn't say it. We do not alert on single negative message. Only if we see two, not distant, too distant from each other, then we alert on it. So we are pretty confident. On a sentence level, we are 65% confident. On the alert level, we are, what is it? 86. On the chat level, we are 86% confident in ours. So our error rate is 1 or 2 chats out of 10, which is maybe too much. We are working well. Yeah.
Do you keep the data about the chat? Like, let's say in the messaging wall, if a customer returns a few days later and he wants to continue a chat he opened 5 days ago, then the agent will see that the previous chat was negative?
No, not in current chat architecture. No. In message, yes. In chat, something that I don't know. Yeah. Sorry. You mean if we do keep the track of the previous sentiment? The question was whether we use it in aggregating the current sentiment or not. I think we keep track of the current engagement to alert on it that it is negative or positive. Okay, thank you very much.
Hi, I'm Neta. I'm a data scientist in LivePerson. And in this part of the talk, I'll tell you about the impact of the sentiment engine and the architecture you've just seen on our customers, the brands. Okay, so I'll start with some general description of the interests of our customers, and then I'll show you some analysis. So what do the brands care about? They care about many things. They care about their internal operations and about their financials. They care about what their competitors are doing, and they also care about their customers, specifically their customers' emotions. And let's see what they do about the customers' emotions in our context, in the context of chats. So in our context, they're using post-chat surveys. And this means that as a visitor to a website, you chat with an agent, and when the conversation is ending, you are popped up with a survey, what we call post-chat survey. And this survey can include multiple questions. For example, you have here CSAT, customer satisfaction question. Please rate your level of satisfaction with the brand. Another example for a popular question is Net Promoter Score, NPS. How likely are you to recommend the brand? So these are the questions that appear in this survey, and the visitor can decide if he answers those or not. And then the company, the brand, collect all these answers of the responders and perform some analysis on this. For example, it can decide to do some actions, improve a website. It also uses it in order to rank the agents and compare between them. So this is what our customers are currently doing. Let's see how what we told you about the sentiment engine comes into play here. So I would like to introduce the Meaningful Connection Score, MCS. This is a metric that we developed in LivePerson that measures the strength of the connection between a brand and its customers. And in the first version that we have now in our product, this MCS is based on the sentiment engine that we showed you. So we have the sentiment engine, and it scores the sentences, the messages in the conversation. And we combine all those messages to one score for a conversation. This is what we call conversation MCS, Conversation Meaningful Connection Score. And now when we have one number that represents the entire conversation, we can derive some other numbers out of it. Let's see these examples. One is the brand MCS, one number representing the strength of the connection between a brand and all its customers. Another one is consumer MCS. We take all conversations of a single consumer and combine the scores to one score for the consumer. Another example is MCS for skill. Skill is an attribute that our agents have. It can be, for example, sales, skill, or service. So we can calculate MCS for sales and MCS for service. Another example is agent MCS. We can calculate the MCS of each agent based on those conversations of this agent. And we have a method to rank the agents based on MCS. And the last example here, line of business. Some of our brands, that our customers, are enterprises. They have multiple departments. And we can calculate MCS for each one of them, for each line of business. So these are all the metrics that we calculate. And let's go back to what our customers are interested in and see how it all fits. So we said that brands care about customers' emotions. And MCS analyzes the chats and gives us insight regarding those customers' emotions. And previously, our customers could use posted surveys. Now they can use the MCS algorithm. So they have a real-time sentiment engine. And they don't need those survey questions. Previously, we had only a responders group to those surveys. Now we can analyze all chatters because we analyze the text of the conversation, so we can analyze all those conversations, and we have MCS that takes into account all the conversations. And as I said earlier, we can use MCS in order to rank the different agents. Okay, so why do we care about this real-time capability that we discussed in the architecture part? So our customers, when they use posted surveys, they have the information about the customer's emotions only when the conversation is over. So they can act upon it only after the interaction is already over. They can send a mail or contact the customer in some way if they have this information about this mail and so on. And now, when we have this real-time capability, they can do these actions during the chat. An agent that has some difficulty can use the agent manager to help him solve the issue while the conversation is going. So this is the importance of the real-time capability. Regarding analyzing all chatters, well, it depends. It depends on what I'll just show you in a second. So when we have the surveyed people, we can split it to two groups. We have the people that respond to surveys and the people that don't respond to surveys. Okay? What our customers typically do is they have the responses of the people that answer the survey, and then they extrapolate it and assume that all the customers think the same thing. Okay? So they take the responders and they say that the non-responders are actually behaving in a similar way. So if it's indeed the case, so it doesn't matter if you analyze everyone or only the responders. But if those groups are different, then it's important to analyze everyone. So usually, our customers, they have no idea. They don't know if those two groups are identical because for the non-responders, you don't know what they think. They didn't answer a survey. Now, when we have MCS, we can do this calculation to check if there is a survey bias. Survey bias is when those two groups are different. So we did the following analysis. We took 95 brands that have NPS survey. It's one of the survey questions that I showed you earlier. And then we could split them to those two groups, the responders and the non-responders. And we could calculate the MCS of each one of those groups. Okay? So what do you think that we found out? Was there two MCS of the two groups? Was it identical? Was it different? Who thinks it was identical? No? No one? Different? Well, yeah. Yeah. If it was identical, I wouldn't be showing you this. It's not very interesting. Yeah. Yes. If they have different MCS value, that means that these are different populations. That's what we're checking here. So what we found out is that for 86% of these brands, the MCS of the responders group was higher. Okay. So actually what we see here is that the people that respond to surveys have higher MCS value. So those two populations, the responders and non-responders, are actually two different populations. When our customers look at this data, they see that there's the responders, they take their responders' answers, and then they assume the non-responders are the same. They're actually over-optimistic. And what we see here that in most of the cases, positive people tend to answer the surveys, more positive people answer the surveys, and then we have this bias, and therefore it is important to analyze all the chatters. Okay, so previously at the beginning, we talked about what are the interests of the customers. And we said that they care about their financials. So we wanted to see if there is some connection between MCS and the financial performance of the brand. And in theory, it works like this. You have your customers that have high MCS, they're happy customers, and then they stay with you for longer periods. And then your retention rate is higher, and since acquiring a new customer is more expensive than keeping your current customers, then you should have some better financial results. So we wanted to see this, if we can see this in our data. And for this, we took our brands, our customers that are in the telecommunications industry, and they're also public companies. And we have 19 of those. And we calculated the MCS for each one of them. The circles that you see here are those 19 brands. And the size of the circle represents the revenues of this brand. So we ranked those brands here on this MCS scale. And then we wanted to see the relation of this MCS to some financial metric. And the financial metric we chose was profitability, specifically operating margin, excluding unusual items. And then we want to see what is the value of, what is the operating margin of each one of these brands. And this is what we found out. So what you can see here is that we have this correlation between MCS and profitability in this telecommunication industry. This is a statistically significant correlation of 0.67. And this is a very important result for our brands, for our customers, because they care about the financials and about profitability. And we see that there is this correlation between MCS and profitability with companies with high MCS values and high operating margin. Now I would like to combine this result with the survey bias that we discussed earlier. And just as a reminder, we talked about survey bias. We took two groups of customers, responders and non-responders. And if their MCS is different, then we say there is some survey bias. So out of these 19 brands, 6 of them have NPS survey. So we can do this comparison and see if they're biased or not. And we found out that 5 of them are over-optimistic. The MCS of the responders is higher than the non-responders. So in order to demonstrate the magnitude of this survey bias, I want to show you the results on this graph. So I wrote here 2 groups, the MCS of the survey responders versus the non-responders. The non-responders have lower MCS value. And now we can see what are the matching profitability values. So we see here that for survey responders, they have 19% of profitability of operating margin, and the non-responders have lower profitability values. So here in this graph, you can see that not only that this bias is statistically significant, it also has this magnitude. Okay, so I would like to wrap up now this part of this of the talk, and I'll say that in the future, as we see it here in LivePerson, MCS will be a metric very important to brands. The brands will be able to get rid of surveys and use only MCS, instead measuring all the conversations that they conduct and assigning it this emotional connection score. And we say this for 3 reasons. The first one is because MCS is calculated in real time during the conversation, like we told you in the first part of the architecture. And the second reason is that MCS calculates the customer's emotions accurately. As we showed you, we are developing this engine specifically for live chat. And as a third part, what I just showed you, MCS correlates with metrics that are important to brands, that are important like profitability. That's it. Okay.
Just one question that I want to just understand. You're saying that the conversations are analyzed in real time. Is there any consideration or any factor or vector maybe for a customer that's really heated? You know, in the heat of the moment, you say all kinds of things. You know, you're literally upset. The box came broken. You're typing at the engine. You know, you piece of shit company, because you just received this broken thing for Christmas. Mm-hmm. And a day later, you're much more calmed down, meaning you're not that upset. Is there any vector? You know, when the customer is like a lot more, you know, he's a little more relaxed. You know.
Yeah. So we take the sentiment responses. Yes, we take the sentiment responses during the conversation. The sentiment engine scores each one of the messages, and then we can aggregate this, combine those scores to have one score for this conversation that takes into account both those parts.
Maybe if he had the chat 2 days later, it would be a lot different than what the MCS would report in real time.
Yes, so one of the metrics that we have is consumer MCS. If we can track that this is the same consumer, sometimes we can't because our customers don't have this information that you're the same person coming a few days, then we can have this score for the consumer that takes into account.
So you do have a consumer, like a total package solution?
We don't have it yet in the product. Okay, thank you.
So hi, my name is Naama. I'm also from the data science team, and I'm the last speaker, so I'll try to keep it light. Okay, so far we talked a lot about the customers, what they're doing, how they're feeling. And now I want to approach our story, the story of service, from a different perspective, and that is the perspective of the agent or the service representative. These are the guys who sit in the contact center and chat with the users, with the clients. Now, usually they're multitasking. They're handling more than one chat at the same time. And they need to be professional, because they need to know how to answer the users, the customer queries. And on top of that, they also need to deal with all of that emotions of the customers. So I'm going to talk today about how these emotions affect the agents. How do they affect the service level that they give? Okay, so let's start. Some people deserve to be recognized. This work is a part of the collaboration that we're doing with some researchers from the Technion, specifically the research lab of Professor Anat Rafaeli, who is an expert in emotion in service systems, and also from the research lab of Dr. Galit Yom Tov, who also deals with service systems more from the operational side. All right, so contact centers. Usually when we think about it, we think it seems kind of gloomy and depressing. And I think this cartoon illustrated quite well. So it says that if you're not completely satisfied, your money will be cheerfully refunded as soon as we can find someone around here who's cheerful. And as often is the case, there is some truth behind it. And these are results of a work where people from multiple countries were asked, who do you express anger toward? And we can see that people tend to express anger more to agents, and specifically, it is the case in Israel. Okay, so we have this gloomy, depressing picture, and we want to know, is this the real, is it true? And we have the sentiment engine, right? The one that Michael described. So the first thing we wanted to do is just look at our data. And in this analysis, we just look at one brand and about 5,000 chats. And we looked at customer lines, and we wanted to see the sentiment. And yeah, most of the lines of the messages do not have any feeling at all. Only about 7% of the messages have negative emotion. So how does this, what can we do with this conflict? I mean, we think about it as a depressing place, but actually, there's not so many negative chats. So one way to handle this is to think about emotions. Emotions are infectious. Do you know how it is when you walk into a room and you feel the bad vibe? Or when someone is anxious and everyone gets anxious? Or when someone is energetic and he's having fun and everyone are following him? So that's how emotions work. There's a lot of studies on this, and it's a true phenomenon, and it might explain what we're seeing here, that relatively there's not a lot of negative emotions, but the effect of this small number is larger. All right, so next we wanted to see the link between these emotions and the agent performance, and specifically we looked at response time. Now, let's assume that I have a problem or you have a problem, and we need to contact HOT or YES, and we want them to resolve our problem quickly. We want a response. What do you think would be the best strategy? To come neutral, to come negative and yell and be angry, or to come positive? What do you think would be the best strategy?
Negative.
Okay. Yeah, someone thinks differently?
Yes.
All right. So our data says something completely different. Generally, when user express positive emotions, the agent answers much more quickly. It takes him about half of the time that it takes otherwise. Okay, so this is an analysis that we did about the existence of emotions. Is this chat negative? Is this chat positive? And we can see that for negative, we didn't see a lot of difference between negative and neutral, nothing significant. So next we wanted to look at the intensity of emotion. Does it make a difference if someone is slightly angry or really angry? How does this affect the response time of the agent? And this is something that we can see here. So we have the intensity, and these are chats which are positive on the green line, and on the red line, these are chats that are negative. And just notice this steep incline. So when users are really negative, the agent response time just goes up, and it might take him more than 3 minutes to respond to an angry user. So we went and we asked the agents, what happens? What do you do when you get a really angry customer? So remember, they're multitasking. They're handling many chats. So they told us, we just put it on the side and answer the other clients. Okay, so this is still a work in progress. We have a lot of things that we're still thinking about, but there are applications to this knowledge. First is when we think about routing. So we know that agents, it takes time for them to to get back to their action after handling someone who is difficult. And we can take this into consideration when we do routing. Maybe if an agent just had a really, really hard call, maybe we should give him slightly like an easier one next. Also for prioritization, agents deal with a lot of messages. And maybe we should just spread the hard messages. Don't give an agent all of the hard messages at once. And the last one is for staffing. So we know that customer emotion, and specifically negative emotion, they have an effect on agents. Agents that deal with a lot of anger from customers, they tend to take more sick days. They don't come to work. And they even resign more. So it's something that we need to take into consideration. All right, so thank you. And I think I'll invite the rest of the team, and we'll be happy to take questions. Okay.
I just would like first to say thank you for everyone, and we will continue the question. Just one thing to emphasize. All our work is based on data. We are data scientists, and we work all the algorithms is driven by data. So there are a lot of hypotheses whether things should be done in one way or another way. We always let the data decide, nothing else. So there are many hypotheses that are raised here. Some might be correct, some might not. We always judge everything by the data, as Michael stressed in his talk. That's all.
Question for Nama. You might have said it already, but I believe people are more impacted by negative emotions and negative experiences. I heard somewhere that the ratio is about 3 to 1. You remember negative experiences 3 times more than positive ones. So you may want to scale your results based on this.
What, 3 to 1?
Yeah.
One hard call and then 3 easy calls?
And the duration of the impact is 3 to 1.
I think that the intensity or the accumulated impact is 3 to 1. If you go to people and say, ask them, did they have a good day or a bad day, based on the number of positive and negative.
Yeah, well, there is some research that shows that indeed that when agents are receiving number of hard calls, then their performance just declines really steeply. So, but I don't know the 3 to 1 ratio rule, but yeah, this is something that is known in voice, but we don't know the exact ratio in chat.
They also analyze the agent type of conversation, the emotional analysis.
No, it's harder for agents.
It does not convey a lot of information.
Yes. It's hard because the agents are trained and they generally don't show a lot of emotions.
My experience with them is that they sometimes look polite, but they don't answer your problems, and this piss off you very much.
Yes, as in the case where they just don't answer, and they answer other chats. Yeah.
What about any data along gender? Women may tend to show more emotions, men may show less, or more extreme emotions.
Yeah.
Like a man may say, fuck you, this is a terrible thing, and a woman may not say that.
You don't need the data science.
Okay. Well, again, I want to put it into context. We are working on this issue of sentiment and the implication of sentiment. Part of it is the research that we are doing with the Technion professors. Part of it is the product improvements that we are doing. At the moment, we did not conduct any analysis that analyzed the gender impact on the sentiment or the agent performance. We are going to do this, definitely, and a lot of other stuff. We've just started.
Yeah, you can also, let's say, the day of the week. I think it's an easier analysis, and we have some results, not final yet. You can guess which days of the week where users are angrier. Yeah.
Is it by brain? No.
What?
By brain?
Well, this is a general analysis that we did so far.
Weekday and weekends are different.
Yeah.
You mentioned before something like prioritizing and routing according to previous sentiment experience of the agent. So are you working on predictive sentiment analysis?
Okay, so there's several ways you can attack this. So first, when I think the easiest way to answer it is when we deal with messaging, then we got the first message, so it's easier because we route only after the first message. And for the case of chat, we did try to predict the emotion based on other characteristics, but it's something that is not finalized yet. So I don't want to.
So I guess
I don't have some results on that.
Okay, so I guess the predictive method is more based on metadata rather than the
Metadata and the journey of the user in the site.
Oh, maybe.
Yeah.
Can you elaborate more, please, on the chat level sentiment when you define a chat as a negative or very negative, if you have that scale? Because is it based only on the specific words and you sum it, or?
Yeah, so the current results that we have, we tend to take the average of the responses of the messages, but we're experimenting with different aggregation methods.
All right.
Thank you.
Thank you.